lattice multiplication. Lattice multiplication is simply another algorithm in solving multiplication. It's just another set of processes that allow you to multiply larger numbers. Now, of course, you can do the smaller ones, which we're going to start with, but this will allow you to really kind of get your hands dirty with those larger numbers. Let's take a look here. 53 times 14 equals, well, we don't know. We don't quite know yet. The way you set up a lattice method of multiplication problem is you have to have a structure, and this structure is either a rectangle or a square. Now, what on the earth does that mean? Well, let's take a look. When you write lattice multiplication, you're going to write the first number there, and you're going to separate them just a bit. You'll see why in a minute. The thing we're looking for, we need to create an alley for each one of those numbers, a vertical alley for each one of those numbers, and then we're going to enclose them. So your alley here and your alley here. You have the 1s and the 10s represented. Then we write the 14, or whatever the other number is, right there. And as you can guess, we need to separate the 1s and the 10s at this point. So now we have alleys for these horizontally. The last thing we need to do, these are what I call addition alleyways. Now, just as in traditional multiplication, some of you parents would probably recognize this. In traditional multiplication, you have to start, well, multiplying. Shocker. So let's start here. 3 times 1. 3 times 1 is 3. You need to have, even if it's a 0 in the 10s, and this is the 10s alleyway, even if you have a 0 in the 10s, you need to write it. Now, 1 times 5. Same thing. Write that 0 in the 10s. You need a number in every single triangle that is on this lattice board. Next, you're going to do these. 3 times 4 is 12. And then we're going to do 5 times 4. Now, why do we need to put those zeros if there's no 10s? Well, this is why. I mentioned I called these addition alleyways. Just as in traditional multiplication, if you have more than one tier of multiplication, then you have to add those together. What you've just multiplied, you need to add it together. In lattice multiplication, you do the same. So let's start with this one. 2 plus nothing is 2. 3 plus 1 plus 0 is 4. 0 plus 5 plus 2, 7. And of course 0 plus nothing is, well, nothing. So you don't need to write anything if it's in that spot. You're left with this number right there. And that is what you record as your answer. 53 times 14 equals 742. Let's take a look at another one. 74 times 23. Set it up the same way. Enclose it. You see we have 2 alleyways going down. We need to do the same thing for our 23. And we have 2 alleyways going across. And of course we need to make our addition alleyways. In this case we have 4. There's a lot of relationships to be said for how many place values are represented in the original problem with how many what I call alleyways we have all over this lattice multiplication problem. So let's take a look here. First thing we do, start multiplying. 4 times 2 is 8. 7 times 2 is 14. Oops, excuse me. 14. 4 times 3 is 12. 7 times 3 is 21. And just to check our math, as always, 4 times 2 is 8, 7 times 2 is 14, 4 times 3 is 12, 7 times 3 is 21. Looks good to me. Now we're going to add our alleyways, but I want to show you one at a time. Let's do this one first. 2 plus nothing is 2. 8 plus 1 is 10. Only one small catch here, just like you would normally do if you're adding anything together. You put the ones down in the number 10, it would be 0, and you add it above the next number. That does not turn into 10, by the way, it's just 1 plus 0 plus 4 plus 2. And we get 7. 1 plus nothing is 1. And this is what we're left with. 1,702. 74 times 23 equals 1,702. Another one. Now you see we have 3 represented here. I'm going to draw my alleys and close my alleyways. And then, of course, I need them going horizontally as well for the 7 and the 4. And then, of course, I draw my addition alleyways. Just so we can keep track, I'll highlight here as we go. 1 times 7 is 7. 4 times 7 is 28. 7 times 1, 7. Starting on the next line, 4 times 1 is 4. 4 times 7, 28. Looks like I made a mistake there, huh? Always check your work. Try that again. 4 times 4, 16. And then 1 times 4 is 4. Now I made one mistake. I need to really check my work here. Starting up, 1 times 7 is 7. 4 times 7 is 28. 1 times 7 is 7. Starting on the next level, 1 times 4 is 4. 4 times 4 is 16. 1 times 4 is 4. I'm comfortable again with how that looks. Alright, now I'm adding. 4 plus nothing is 4. 7 plus 6 plus 0, is 13. And as we know, we just drop the 1 and add the tens place, which is just a 1. 1 plus 0 plus 8 plus 4 is 14. Add that 1. Don't forget to add, and carry is what we call that. On the next one, 1 plus 2 is 3, plus 7 is 10, of course plus 0. And then add the 1 there. 1 plus 0 is 1. Now to just write this out, 1, 0, 4, 3, 4. Come over, put my comma. So 141 times 74 equals 10,434. Lattice multiplication simply breaks each place value up. It may look busy, but if you trust the process, it'll get you to where you need to be. And this is where you need to be. One more, one last one. It's a biggie. 982. I'm going to go ahead and make my alleyways. And I know it's going to be bigger here. You see my alleyways there? There we go. 1, 2, 2. Make my alleyways for these numbers. You can continue if you have a large enough piece of paper or even the whiteboard here in the classroom. You could get an enormous number multiplied by an enormous number as long as you trust the process. We're missing our addition alleys. And I think we're ready to go. I'll try to keep with this highlighter so you see where my eyes are seeing. 2 times 1 is 2. 8 times 1 is 8. 9 times 1 is, of course, 9. Take a deep breath. Next level. Just step by step. 2 times 2, 4. 8 times 2, 16. 9 times 2, 18. Take a deep breath. I made one mistake. I don't want to make another one. 2 times 2, 4. 8 times 2 should look familiar. 16. And another look familiar here. 9 times 2, 18. I am going to check my work. Starting way up at the top, I'll go quickly. 2 times 1 is 2, 8 times 1 is 8, 9 times 1 is 9. 2 times 2 is 4, 8 times 2 is 16, 9 times 2 is 18. 2 times 2 is 4, 8 times 2 is 16, 9 times 2 is 18. Alright, highlight it down. Now it's time to add. We've got our grid all figured out and multiplied out. Adding one at a time. 4 plus nothing is 4. 4 plus nothing plus 6 is 10. And way up here, look at the 2. There we go. I'm going to add my 1 up there. 1 plus 2 plus 0 plus 1, I know. That's right, it's 10. Plus 8 is 18. I am going to go back and check that one just in case. It's always the easiest ones that you tend to slip up on. 1 plus 0 plus 8 plus 1. That's 10. Plus 8 is 18. Plus 1 is 19. Boy, oh boy, I'm going to have to check that one too. Don't forget to carry my 1 here. Make it a little bit pronounced. 1 plus 0 plus 9 plus 1 is 11. Add my 1. 1 plus 0. 1. Boy, oh boy. Let me check one more time. 4 plus nothing is 4. 4 plus 0 plus 6 is 10. Carry the 1. 1 plus 2 plus 0 is 3. Plus 6 is 9. Plus 1 is 10. Plus 8 is 18. Carry the 1. 1 plus 0 plus 8 plus 1 is 10. Plus 8 is 18. Plus 1 is 19. Carry the 1. 1 plus 0 plus 9 is 10. Plus 1 is 11. Carry the 1. 1 plus 0 plus, 1 plus 0 equals 1. You're not done. Do not dare leave it as it is. You write all the numbers out in order. Excuse me. Drop to the next page there. There we go. Sorry for the confusion there. Throw your comma where it belongs, and there you have it. 982 times 122 equals 119,804. Doesn't matter how big your multiplication problem gets. If you use the lattice multiplication and trust it step by step, being very careful along the way, it's yet another method of multiplication you can use whenever you feel you need to use it.